Hello, I'm going to teach you how to do Newton's method on a calculator, and I'm going to use this equation or this question from page 25 in our notes to do it. So we're given a function, we're given that it has one positive solution, and we know that it's around here. That's about 1.9, so 1.2, 1.4, 1.6, 1.8, and then 1.9 is halfway between 1.9 and 2. So I start with the function, I always get the derivative, and then I can put those two things into the calculator. So you bring up the y menu on the top here, and you press x cubed minus 3x minus 1. That's my first function. Put the derivative in below it. Alright, that's my two functions there. I'm going to quit out of this, and then the calculator is going to do a lot of the rest of the work for us. First, we need to put in our initial guess, 1.9. So just type 1.9, press enter. That'll save it as a kind of recallable function or recallable value in the calculator. And then I'm going to set up my Newton's method here. It means that I take my guess minus the function evaluated at that guess divided by the derivative evaluated at that guess. So my answer is my initial guess minus, and now I need to call my function. How do I do that? I click variables, go over to y variables, and press 1 for function or press enter, and then call my first function. Now I need to tell it what value to evaluate this at, so I open a bracket, toss my answer in there, close the bracket, that'll be 1.9. And now divide it by the derivative, so go to variables again, vars, go to y vars, go to function, go to the second one or hit 2. That's going to be my original function evaluated divided by the derivative evaluated at the answer. So evaluated at 1.9. And this is where the real spicy part comes in. This is what makes this method really good on a calculator. When you press enter, you get your first increment, or you get your second guess, or your better guess. So I wrote 1.8797 because it said 1.87969, so I just rounded it and ... for the rest, because you could write this whole thing out, but there's no need. In the second step, I'm saying, well, I'm going to take my x1 and I put it in here. My new guess, my x2 after this, will be x1 minus the function evaluated at that divided by the derivative evaluated at that. But I don't need to change my calculator at all. I just can say second enter. It recalls. It'll recall based on answer, which is now my previous answer, my previous guess. I press enter. I got a new guess. And I wrote that down. The really amazing thing is that you don't even need to press second enter if you haven't changed anything. If I press enter again, it'll give me my next guess. If I press enter again, it'll give me my next guess. So that's pretty amazing in my opinion. So let me just remind you what I did. 1.9. And you say answer minus, call your function at the value divided by your derivative at the value. Enter, that's your first better guess. Press enter again, that's your next. Enter again, that's your next. Enter again, that's your next. You can go on forever. When the decimals repeat like this, you know you found your root. So I said that the root is about 1.8794. I actually could have said the root is 1.879385242, but I didn't want to. But that's how it's done. Let me know if you have any questions.